All right, here, quiz 3 from 2016, unit 3. For this first one, you have cocaine, not penicillin, sorry, it's supposed to be cocaine. Start of the asymmetric centers, so we're looking for sp3 hybridized atoms with different things attached. So there's 1, 2, 3, 4. sp3 hybridized, 4 different things attached. How many stereoisomers are possible? So if we have 4 asymmetric centers, it would be 2 to the n, where n is the number of stereocenters. So 2 to the 4th is 16, so that's 16 possible stereoisomers. Identify the stereoisomers in this molecule as RS. So this is actually neither, because as you go, you can't rank these ones. You can't differentiate these because they're both, there's some symmetry here. This one is S, this one is R. If you want to draw a diastereomers molecule, you keep, this doesn't change at all. You keep one the same, keep one as R in this case, and then you switch the other one, right? Diastereomers, these two, relationship between these two, they're diastereomers because one is the same, one stereocenter is the same, and at least one is different. And there's another option as well where you keep this asymmetric chiral center the same, and you switch this around. Now the molecule itself is achiral. It's actually achiral and meso. It has asymmetric centers and has a mirror plane, so it's actually achiral, and it's a special type of achiral. It's actually meso. For number 3 are Fischer projections. So you gotta remember Fischer projections, that bow tie. So H and OH here are wedged, they're coming out. The aldehyde and this other piece down are going away from us. Rankings were key here. Oxygen is red, has the highest molecular weight. Aldehyde is white, H is green, bottom one is blue. So it ends up being priority with 2, and then it ends up being R. So here's some matching. Compound with the same molecular formula but different chemical bonds, that's a constitutional isomer. An atom attached forward in the group without pi bonds, that's an asymmetric or chiral center. Compound with a non-superposable mirror image with no mirror plane, that would be a chiral compound. And then stereoisomers, so 2 compounds that are not mirror images, that of course is diastereomers, which you've seen before. Here again, identifying E and Z, doing some rankings, splitting it down the middle, cutting it down the middle. Oxygen versus carbon, oxygen wins by atomic number. Carbon's a tie, but then this carbon is bonded to 2 other carbons and an H, whereas this carbon is bonded to 1 carbon and 2 hydrogens, so this has a priority, so they're on the same sides, that'd be Z. Over here, split down the middle. Sulfur is nitrogen. Sulfur has a higher atomic number, so that's higher priority. And very similar before, it doesn't matter the iodines are here. We do 1 bond out at a time, so these actually are opposite. So this would be E. A little nomenclature here at the end. 5 or hex 5-ene 1 all. What you'd have here is 6 carbon hex 1, 2, 3, 4, 5, 6. 5-ene, so that means the pi bond starts at 5 and goes to 6, and 1 all. That's where the alcohol is at. Good tough one here. This is chiral because it does not have a mirror plane, right? So this is actually an allene. So it's a section in our book at the end of chapter 12 if you want to take a look. But this does not have a mirror plane. People did an excellent job of identifying that.